Hi everyone, today I'm excited to present to you Student Sidekick, which is an intelligent document assistant that helps students get instant answers from their formal academic documentations, such as the degree statutes for an example. But before I get into it, let me share my motivation. As a student who is mostly pressed with time, I know sifting through loads of academic documentation for information can be a hassle. That's why I'm trying to simplify the process for other students by creating a chatbot. Before getting into the technical part, I would like to show you how it works. You can first upload a PDF, as you can see in the current slide, or you can input a URL. But for our example, we will be working with uploading the PDF. Once uploaded, the app uses advanced NLP or natural language processing techniques to understand the document. It combines two powerful search methods, semantic search that understands meaning and keyword search for precise matching. Okay, so far we've been able to accomplish a few items in the pipeline so far, but this is a representation of what the pipeline we are following. So as you can see, we started the process by uploading an academic PDF. Alternately, the system can fetch a PDF from provided URLs. This step ensures the document is accessible for further processing. The next thing we did was text extraction. So using a Python package called pdfminer.6, the system extracts raw text from the PDF while preserving the structural elements, such as the paragraphs and headings. Some challenges arise. So, like let's say there is scanned pages or complex layouts. These are not being able to be handled very well. But in the future, using other packages such as OCR, we're able to fight over these challenges. Okay, so as you can see, we've been able to chunk and embed. What this does is it basically extracts the text and it splits it into meaningful sentences or passages, and this is what we call chunking. So using NLTK's sentence tokenizer, each chunk then converts into a numerical vector. In other words, that's the embedding. And we use the pre-trained sentence transformer model. What we used was the mini LM-LX L6V2. These embeddings structure semantic meaning for later search operations. Okay, so now that we are done with the embeddings, we can store the embeddings in a vector database, which is the next step in the diagram you can see. So the embeddings are stored in a lightweight memory database via another package known as Pickle. This allows efficient retrieval during queries without reprocessing the entire document repeatedly. Okay. Then when that is done, our search query can be inputted. So this is the place where the students naturally submits like a natural language question. For example, how many years is the computer science major? The system treats the query as the starting point of knowledge retrieval. As you can see, to our question, how many years is the degree program for communication studies? You can see that we've been able to get an answer from our chatbot. And yeah, the answers are a bit long, but there is important information that can be found within the text. Now, in the future, by using more quality APIs and LLM models, we'll be able to shorten the reply of the chatbot and make it even way more accurate than it is at the moment. In order to understand how our chatbot was able to come up with responses, I used a hybrid search strategy. For this strategy, I combined two methods. The semantic search, which works by measuring the similarity between the embeddings of the query and the document. This basically helps the system understand the meaning behind the words. And the next strategy I used in combination with the semantic search was keyword search. Using the BM25 algorithm, which focuses more on the exact matches of the terms. So that is, you search for a term and then the terms are looked for in the document in order to come up with the meaning and construct a sentence. Moving on to the seventh step, which is the context assembly. So what we do is we match the top text chunks, which are aggregated into a coherent context window. This ensures the generated response is grounded in the most relevant parts of the document. So once this is done, now we can come up with the response generation. So this basically puts the context together. Okay, so the system generates a short and student-friendly answer. Right now, it uses a set of rules like link common academic questions to predefined templates. But later on, I'd like to explore using LLMs like GPT or other APIs that allow for more advanced and flexible responses. So after all this is done, we're able to get our final output. So the final answer is shown in a clean chat-style interface with formatting that makes it easy to read. It also includes citation points where the information came from in other source text. So this allows the user to be able to go back to the referencing just to find out where it was. It also saves a lot of time. So moving on to the key features of our student's sidekick, it was designed to feel as natural as chatting with a study partner. Just ask a question in plain English, no complex commands or syntax searches. Whether you are tired after a lecture or rushing before an exam, the interface simply stays friendly and easy to communicate with. And also, a lot of effort was put into the graphical user interface. The graphical user interface was created using Streamlit, which is also another Python package. That's what allows our code to be able to run in such a beautiful interface and not within the dedicated code spaces. As you can see, I tried to make it in such a way that everything is easily and readily seen. What you can do is straightforward to the point to prevent any form of problems that students might face in the future. And also, there is a fast document processing aspect to it. I added a cache memory into it, so if you've worked with the PDF before, it's going to be saved into the cache memory, and next time you want to load the chatbot, you don't have to re-embed everything. Everything is going to be right there in front of you. Unless it's the first time you're doing it, then you have to re-embed everything. But if it's the same document you're chatting with on multiple locations, it will be as fast to generate responses as you can type your questions. Moving on to the usability, we can in fact see that the chatbot is in fact accomplishing its goal by helping students be able to read academic documents such as the degree statute. But also, in fact, anyone needing to extract insights from documents could use this chatbot in order to accomplish that goal, since it's going to read any PDF that's uploaded to it or a URL, in fact. Researchers can also analyze their papers using this PDF document, since it does return answers which are in line with the question asked. In the end, I just want to say Student Sidekick represents how AI can transform learning and information retrieval. It's not about replacing study or the hard work in finding information, but about making it more efficient and effective. Also, before I wrap up, I want to highlight something important. Every tool used to build Student Sidekick was 100% free and open source, from Streamlit for the interface to sentence transformers for AI. Now imagine what I could do with more time and resources. For one, I could fine-tune the model, add multi-document support, or even add voice interactions. The potential is very huge, but for now, I'm very happy with how far I've come with a €0 budget. Thank you very much for your time, patience, and understanding.